Welcome, everybody, to the Daily Space Weather Show. If you're looking for the world's most comprehensive daily space weather and most detailed imagery of the sun, you've come to the right place. By the way, I'm your host, Dan, a.k.a. Smash-O-Mash, and this is the Smash News Network, least busted name in news. Let's get to it. Coming at you a little bit late today because of a severe thunderstorm last night. That's a 24-hour video featuring ionized iron and helium, 193 plus 304 angstroms from the Solar Dynamics Observatory, and you may see filaments littering the Earth-facing portion of the solar disk. We've seen a very low number of solar flares, a low background X-ray flux, and a low radio flux. Also, almost no coronal mass ejection activity in the past 24 hours, which is surprising. Is it the calm before the storm? We've also got new sunspots that have risen and formed in the eastern limb. Here's one of those new sunspot groups. We'll show you more detailed imagery of that here momentarily. First, the northern hemisphere, and there is another crown prominence hanging out up there just to the west of the Earth's scale. You can see that represented as a dark absorption feature. Now, the most likely place to see large solar flares is the western limb. There are two major sunspot groups setting. I would say especially the one in the northwest is the most likely to produce a large solar flare. And again, there are filaments all over the solar disk. Several of those have names. Several of those have potential to get names. We've been naming them after living people. Here's that most likely sunspot group to produce a large flare. It is quite magnetically complex, and the closer and closer it gets to the limb, the higher the probability of a large flare. So you can expect that one, unless it suddenly degrades to an alpha-class sunspot, to be likely to produce large flaring activity. This group in the southern hemisphere a little bit less likely, although it is approaching the limb also, so it does have some opposite polarity umbrae trailing the main very large umbra of that sunspot. Here's a southern hemisphere, and a new sunspot did rise right over here in the southeast. So that is a sunspot. It's looking pretty large already. We'll show a greater detailed analysis of that before we get to our meteorology segment. So let's take a look at sunspots here. Here is the SDO continuum. Some sudden evolution of this group up here. This one here is degrading, actually, over the past 24 hours. This depicts yesterday plus today so far, so August 12th and August 13th to date. Now, there is a small pore right here, and a larger group has opened up ahead of it. So that is a beta-gamma class group, at least. It might even be beta-gamma delta class. And then, of course, this new sunspot down here. So far, it looks like it's only alpha class. Here's colorized magnetogram for that same time frame, yesterday plus today. And let's see what's going on the Earth side of things, like the surface of the planet. Things like lava and ash and steam and gas are coming out of the planet. Let's see where it's happening. Stromboli, the world's tastiest sounding earthquake. Increased activity there in the Aeolian Islands from Stromboli. Lava continues to flow, active, increasing its length down the Sierra del Fuco. I believe it's the northwestern slope of Stromboli. Abico also erupting, producing a 12,000-foot ash plume. It's a flight level 120. Unknown size volcanic ash plume there over Mount Mayon. Semeru exploding, producing a 15,000-foot ash plume. It's a flight level 150. Flight level 210 over Ecuador from Sangay. Continuous ash emissions from Sabancaya. No altitude listed there. Ubinas also exploding. Flight level 220. It's a 22,000-foot ash plume over Peru. A great reminder to not pole vault the caldera. Here's a reminder to visit our links. You'll find them below the video. If you enjoy the content, help to keep it existent, publicly visible, and free for all to view by becoming a member of the Smash team, visiting our links via smashomash.com. You can find this at the merch shop. You'll find a Smash-O merch link on our homepage, as well as a link to the Redbubble shop below this very video. Over 30 different merch designs there, and all of them available on various different products. I wore the Do Not Pole Vault the Caldera socks yesterday. This public service message brought to you at massive personal risk and expense by Smash staff and I. If you're going through hell, keep going. If you're going on a volcanic vacation, leave that vault pull at home. Don't pole vault the caldera. And let's check and see what's going on seismically on planet Earth. It's been pretty calm here, only moderate activity over the past 24 hours. We'll report quakes of a 5 magnitude or higher. So here we've got a 5.1 at Sulawesi, Indonesia. Sulawesi, there we go. Sulawesi, Indonesia. Now I've said it. It's that occurred. That's a 5.1 at 13:20 Universal Time yesterday afternoon. After that, no 5 magnitude quakes for an extended period of time until the trend breaks at 1:43 Universal Time at the Philippines. That was a 5.4. Then a 5.7 strikes Papua New Guinea. That was at 4:09 Universal Time this morning. And that was the largest quake of the past 24. Last but not least, there was a 5.1 near Greece. That was at 7:49 Universal Time this morning. And we're going back. We're going back to space. 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 We're going back to space. Yo, I think so. That's another 24-hour video from SDO, the Solar Dynamics Observatory. 171 angstroms is the house favorite wavelength. If you've got a favorite wavelength from SDO, let us know in the comments what it is. We're always interested in the preferences of our viewers, and we do indeed read all comments. Although we may not respond to them all, we will read them all. Looking at some additional space weather stats here, the 10.7 centimeter radio flux, now all the way down to 148 solar flux units. 148, the new radio flux number. There's the black line depicting the 1-year trend of the 10.7 centimeter radio flux. And you may see an upward trend here, connecting the dots. There you go. It's solar cycle 25, and we're still like a year out from solar maximum. If you think we're already at solar maximum, what the heck are you watching on YouTube? Are you watching nonsense on YouTube? Please stop watching nonsense on YouTube. Nope, just kidding, folks. There may be valid propaganda on YouTube that you'd have a good reason to watch or something. Space Weather Enthusiast dashboard here, forecasting nothing but geomagnetic calm conditions for the coming 3 days, and I would tend to agree. There is no space weather on the way. There is some indication that there could be a coronal hole intensification, which we'll get to here in a moment. A coronal hole high-speed stream is probably on the way. Let's take a look at Earth's magnetic moment from space before we go into any of that other type of space weather stuff. So here are the past 4 hours of Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. And this imagery depicts magnetohydrodynamic pressure to about 12 Earth diameters. Again, that's the last 4 hours, our Geospace Magnetosphere movie for the day. And here are the past 4 hours of Earth's magnetic moment from the ground. Again, very geomagnetically calm. This depicts magnetic flux density, the units of which are nanotesla. So quite calm here. When we do see an uptick in space weather, there should be quite a significant signal. KP index is an average of global geomagnetism, currently at 1.33. I think it was the same as yesterday's video. 1.33 is the KP index. And let's move to the ghost magnetometers. Oops, first the real-time solar wind. And like yesterday, a very diffuse and slow solar wind speed and density. So solar wind density here only 1.3 protons per cubic centimeter. Solar wind speed here right around just a nominal level there, 405 kilometers per second. Ghost magnetometers here fairly smooth over the past 3 days, since there have been no solar storms, no significant space weather of note. No major changes to the GOES magnetometers there. No major undulations of Earth's plasma. Now let's take a look at the Sun's plasma. Here's our top view ecliptic plane field plot. And Earth remains in a South Pole current sheet, depicted there in red. North Pole current sheet depicted there in green. Let's move on to our line of sight field plot. There is the Sun's B field depicted in blue. And once again, polar fields in green for north and red for south. You can expect this to get even more chaotic in the coming year or so, as, again, we're still like a year out from solar maximum. And let's take a look at coronal holes. So there's our coronal hole line of sight field plot. And we've got some South Pole oriented coronal holes here near the solar equator, just south of it. And let's take a look at the SDO imagery of coronal holes. There you go. There's the past 24 hours. So we've got both a north and a south pole coronal hole here on the Earth-facing portion of the solar disk. This one here is north. And this one down here is south. There could be an intensification of the solar wind from one or even both of those coronal holes. The northern one is a little bit ahead of the southern one, as you can see on the imagery. And let's move to sunspots. Here are the flare monitor, the ASAP flare probability. And again, the most likely place for a large flare would be up here at sunspot 3395. That's going to go on for days, probably, although it has been degrading a little bit. Second best choice for a large flare would be down here at 3394. So that's what's going on with solar flare probability and sunspots. Let's take a look at sunspots in... This is our SDO magnetogram. That's a 24-hour video. And you can see not a lot of huge changes happening here. Again, this sunspot up here did evolve a little bit. This one down here did degrade a little bit, but no major changes happening. A new sunspot did form here. So this one's promising. This one looks magnetically complex. Let's switch to the SDO continuum here. So here's another 24-hour video at 30 frames per second. You'll see this new group form up here. It is at least beta-gamma class. Oh, and this group down here grew a little bit as well. So a small uptick here in the sunspot number coming today. There should actually be 3 new named groups over here in the east. First, this one has been here for a couple of days. This one should get a name today, and then this new one that just rose down here should also get a name today. Next, we'll talk about energetic particles and solar flares. Now, solar energetic particle events are when the sun blasts out particles that are moving at a significant percentage of the speed of light, known as relativistic particles. That's what the GOES proton flux is referring to. These are high voltage protons, and it shows 3 different voltage levels there. The greater than or equal to 10 mega electron, 15 mega electron, and 100 mega electron volts. That has been subsiding. Don't expect that to continue. Expect more and more solar energetic particle events for the next 2 years as we ramp up and then back down from solar maximum. The background flare profile has dropped into a B8 about a B8 range, a little over B8. There's the most recent background, all the way down to a B7.9 approximately. For the background flux, that is the GOES X-ray flux over the past 3 days. 2 different spacecraft there. And by the way, folks, if you weren't aware, the X-ray flux has to be measured from space. We can't measure X-rays from the ground level, as they never make it to the stratosphere. They're filtered out by the time they reach the mesosphere. So they're measured from space only. And let's take a look at solar flares here from our 94 angstroms 24-hour video. Once again, is the SDO ionized iron there. We'll also show 131 angstroms, another species of ionized iron. And the difference between these is that they have different numbers of electrons in their shells. They are also depicting different temperatures. 131 angstroms is the hottest temperature depicted from the SDO imagery. And man, oh man, there are a lot of huge solar filaments right now on the Earth-facing portion of that solar disk. Next, we'll move to just a chart of the sky as we step back and take a look at what's going on overhead. We encourage you to do the same. One of the ways you might want to do that is via skyandtelescope.org's star chart, and let us know if you saw any Perseids, especially if you took time-lapse imagery of them. Hit us up somewhere, like on the Discord channel, which you can find a permanent invite link to on smashomash.com, or on social media like Instagram, or perhaps the platform formerly known as Twitter. So this is where things are now here over Lehigh Valley, as Venus slowly becomes a morning star here instead of a dusk star. Jupiter here high on the ecliptic as we make the video, and let's do a solar system forecast. There's where things are today. Let's see where things will be in a week. There's where things will be in a week as Venus speeds past and Mercury catches up to speed past both planets. In 1 week we will have a crescent waxing moon. And let's move to our astronomy photo of the day. So apod.nasa.gov is where you can get this photo of the Sombrero Galaxy. So that is actually a Hubble Space Telescope image superimposed with infrared imagery. Sombrero Galaxy is really cool because it's at a really great orientation. It's at an orientation such that you can see the galactic core right in there, and you get a great view of the disk and fantastic contrast. And it almost looks like a bunch of empty space in there in the center. Ultimately, it's probably not, but some galaxies do have a ring-like feature like that. So, Sombrero Galaxy there in infrared superimposed on some Hubble imagery that is credited to various different telescopes there. Caltech, NASA, Jet Propulsion Lab, and SSC. I'm not sure, is that the Spitzer Space Telescope as well there? The Sombrero Galaxy. It's about half the size of the Milky Way galaxy, known as M104 in the Messier catalog. And let's move on to coronal mass ejections. Yeah, coronal mass ejections. They have been quite minimal. Let me refresh that. There we go. Get it going back forward again. So only outflows here in the past 24 hours. It looks like only a tiny diffuse CME there out of the southwestern limb. No major CMEs here, and this is going to be the calm before the solar storm, as the likelihood of CMEs is now 99.9% once again. We realized a couple of years ago that we could forecast coronal mass ejections. We just stopped doing it because it did absolutely nothing to boost our views on YouTube. You'd think that would be a boosting of the views. People would want to know when CMEs are going to occur before they leave the solar corona. It didn't gain a bit of traction, so we just stopped doing it because if it don't make dollars, it don't make sense. Here are today's images. Those were yesterday's. Here are 36 additional frames from today. And yeah, there you go. That's a very low amount of coronal mass ejections. One last thing about what's going on in space. Actually, we've got lots more things about what's going on in space. There's the SOHO LASCO C2 and C3. And before we refuse to show the stereo A imagery because it's looking all jacked up. Yesterday marked the 5-year anniversary of both the launch of the Parker Solar Probe, as well as the day that that happened. The day that Stereo A, represented by this red circle, moved in front of Earth. Now it's slightly ahead of Earth, orbitally speaking. Of course, Earth and Stereo A are moving this way. Stereo A is moving faster than Earth. And Stereo B is now on the opposite side, which makes Stereo B actually ahead as far as seeing space weather, and Stereo A is now behind, seeing older space weather than Earth does. So, after 17 years, Stereo A has made its first pass. So there's the way Stereo A operates. If you weren't aware of the location of the spacecraft, that is what it is doing. And here are our custom videos. That is Soho Lasco C2 and C3. And basically, no CMEs to report here. So, again, a huge number of filaments on the Earth-facing portion of the solar disk. Expect CMEs coming in the next 24 hours. And they could be major. They could be earthly directed. There are a whole host of filaments that are kind of pointed right toward Earth. They won't hold on forever. Some might collapse. Some might eject. Some might reposition themselves. We'll keep you posted on that. And here comes a custom video. And I'm not sure what's going on with this feed. It sure looks funky. What do you think? That's a 24-hour video of SDO 193 angstroms. And then you've got the Soho Lasco C2 coronagraph there. And I don't know what's going on with it. It looks absolutely bizarre. And yeah, I've got no explanation. If you've got theories, let us know in the comments. And now we're going to move on to filaments. So let's show the 193 angstroms wavelength by itself. There you go. This wavelength is great at showing active regions, coronal holes, and the extended corona. Also, it is pretty good at showing filaments. So you can see a bunch of dark absorption features, not to be confused with these coronal holes like this area and this area. Most of the rest of those dark absorption features are indeed plasma filaments. So just like these prominences over here, you can see them hanging off the limb. These filaments are pointed at Earth. So that's exciting stuff. And here's 304 angstroms. 304 angstroms is also quite good at showing plasma filaments. Now you will see some reorientations happening here. For example, up here there's some motion happening right in here. And those largely didn't eject. So, but there are a huge number of filaments, and let's take a look at those. Here is the El Teide, Spain ground-based solar observatory. So we've named a number of these filaments. If you want to name filaments after living people, join us over on X, the platform formerly known as Twitter. You'll see one of these reorientations happening right up here. You can see some plasma rising up and then looking like it splashes back down there. It doesn't appear to have ejected. If it would have ejected, it would have been a really obvious CME. There is a southern crown prominence and a northern crown prominence. And several of those are already named. So again, see us over on Twitter. Here's the same imagery, but in grayscale, and it actually shows the edge of the solar disk, so it does show prominences. So another huge prominence up here as well. So possibly another active region rising there. This is the Donna Marie filament. This is the Kate Bush filament. This is the Mary Grace filament. This is the Mike Smith filament. So there are multiple filaments that could get named here, namely this one down here. I'm thinking of naming that one the John Paul Tremblay filament, or perhaps the Pat Roach. This one up here could get a name. This prominence up here could get a name. And this southern prominence or this northern prominence, or both could get names. So I think it's a good way. I think it's a good idea to name them after living people. It really helps to keep track of them and, of course, monitor their ejections. Of course, if you have a solar storm, then you can name the solar storm after the person too. We name them after living people. And let's take a look at the last couple of hours here on the closest star. There's the GOES 16 SUVIs, last about 2.5 hours. And things are looking pretty steady here at the moment. This prominence up here in the northeast is quite huge. And that brings us to bonus features. And our first bonus feature is satellite charging hazards. We don't have any. There are no high energy electrons or low energy electrons messing with satellites. No surface or internal charging hazards at the moment. The GOES electron flux here just in a sort of a normal range there, a little bit on the high side, and looking like both the GOES 16 and GOES 18's measurements will be moving into warning levels here shortly. Keep in mind it is just after midnight local time for the GOES 18 there, represented by that red M on the right side. Let's see about what's going on in the past year. There's the 1-year graph of the electron flux, just so you understand the context of that 3-day chart we just showed. And here is the forecast. I would tend to agree with that. I was going to say it's looking like it's going to go a little bit higher here than yesterday, and it looks like NOAA would agree. So now again, we may see some coronal hole high-speed streams coming in a day or two, probably more like 2 days. So perhaps that's what NOAA is forecasting with these dips. And if we do see a significant coronal hole wind stream, which, by the way, we've had a shortage of coronal holes throughout this entire solar cycle, in my opinion, if we see a major coronal hole high-speed stream, then indeed we might see a deeper dip. So these electron flux levels might be quite a bit lower than what the forecast depicts there, but no arguments here at the moment. And let's move on to our videos of the ionosphere. And we put up this pane every day just so people understand the temperatures of the Earth's atmospheric layers, depicted over there on the left. In the center, the penetration of atmospheric radiation. So, like I said earlier, X-rays never make it to the stratosphere. They're adsorbed by the time that they reach the bottom of the mesosphere layer. And then on the right side there, you can see visible light and IR. They make it all the way down to the surface, all the way through the troposphere. By the way, the troposphere is where all weather occurs. And plane contrails in the troposphere are not geoengineering or added chemicals. They're not solar radiation management or anything like that. They are man-made clouds and little else. It also depicts the density of chemical concentrations there over on the right. And here is the ionosphere in its vibrational glory. So this is the layer where the GOES 16 and the GOES 18 measure the electron flux. And what you're looking at here is the vibrational frequency in megahertz, millions of vibrations per second. 300 kilometers up is space. This gas is very diffuse, and this does give us insight into things like geomagnetic storm conditions, and that is certainly not what's going on now. Things are quite calm. We'll show the anomalygram also because this might look this might look like Greek to you. And we don't blame you. It looked like Greek to me when I first started looking at it as well. Here is the anomaly in megahertz from the 30-day median. It's one of our many data archiving services that these videos create. When you immerse yourself in the data, folks, you never know when you're going to uncover something previously undiscovered. So it might seem pointless, and it might indeed be pointless, but sometimes you don't know that until the future. Here's the latest image, 12:15 universal time on the ionogram, and it looks like some high-frequency anomalies there, indeed. Here's the 12:15 universal time anomalygram. Total electron content is free electrons to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with these distances in miles. Here is the total electron content forecast. And this is looking fairly orderly as well, as it typically does when we see higher levels of electron flux. This gets a lot more chaotic when we see low levels of electron flux, which is common during geomagnetic storms, things like coronal hole high-speed streams and coronal mass ejection impacts. At the moment, things are looking fairly normal. These are the most likely places to see GPS errors. We also like to show the North American total electron content. Unfortunately, the anomalygram that we normally show is not loading. And it looks like there are some issues with the data here, as we don't see any variations on the standard deviation or the total electron content for North America. So let's just ignore that and move on and close out the daily space weather portion of this video with the latest intensitygram and latest colorized magnetogram. So first, let's look at this new group. And what do we have? What do we have? It is an alpha class sunspot so far. I don't see any umbrae besides that leading south pole umbra. So that's alpha class. And I think that's a new group down there also. Check it out, folks. We found a new group by accident in this it's also in the southeastern limb there. Let's zoom back out here. So yeah, there's a new group. It's pretty small. This group up here a little bit more interesting. That one is beta gamma class. And there are some tiny deltas there, so that could produce some flaring. This one here is still alpha class, very magnetically simple. This group down here is beta gamma class. This group here, good question. That one is beta gamma delta class. So not only is its proximity to the limb making it more likely to produce large flares, its magnetic classification is making it more likely to produce large flares. This group over here is just beta gamma class, I think. That one's just beta gamma class. So that's a more simple sunspot group. And let's see, here we go. Here's the full disk rock back. And let's move on to meteorology. So we're looking at sea surface temperature anomalies to start things off here. And here we go. There are the sea surface temperature anomalies depicted in the color gradients and ocean currents, surface currents, depicted by the animations. Now keep in mind, this imagery only shows surface currents. Those are mostly driven by winds. The deep water ocean currents are mainly driven by heat transfer. So thermodynamics really drive deep ocean currents. Shallow ocean currents are driven by the wind. So that's what's going on in the Atlantic. Let's take a look at the Arctic. And I think it's noteworthy to cite that it looks like there is some very warm water here all along the northern shores of Asia. So that water is anomalously warm for this time of year. That's what's going on in the Arctic Ocean. Although melt season is running out, folks. We are running out of melt season, so it's going to start refreezing quite soon here as we approach the month of September. Here's the world's largest heat sink, the Pacific Ocean. There's a lot of water in there, and it indeed retains a ton of energy. The equatorial portion here is slightly anomalously warm. Also quite anomalously warm there in the northern portion of the Pacific Ocean. There is a band of cold water here, stretching all the way from San Diego to Hawaii and beyond. Here is the Indian Ocean, mostly on the anomalously warm side, and here's the Southern Ocean. It looks like it's mostly anomalously cold, close to Antarctica, and where it borders the other oceans on the anomalously warm side. Anyway, that might not be considered meteorology to you, so let's switch to our winds. These are the surface winds of the eastern world Here are the jet streams of the eastern world. Jet stream blowing backwards here over the western Pacific, the equatorial western Pacific, where those backward jet streams are more common. Here are the jet streams of the central world. And like sands through the hourglass of time, these are the surface winds of your lives. Here are the surface winds of the West, aka the Americas. Some strong north to south wind flows here in the north central U.S. Here are the jet streams of this side of the planet. A strong anticyclone here, probably in the form of a heat dome, right over Washington. That clockwise rotation indicates a high pressure zone. It's probably going to be sunny, and it's going to be hot. Very, very hot. Let's take a look at waves, as I am a wave chaser. So here are the world's largest waves. They are just south of Japan there. They're only about 32 footers, which means the oceans are fairly calm here at the moment, overall speaking. Of course, the Southern Ocean tends to be the least calm part of the world as far as waves go. You can see many areas there, but not quite as large of waves as the ones in the the northwestern Pacific there, south of Japan. Next, clouds and fog over the Americas. And that is the shortwave radiation map, part of the interactive weather satellite suite, the NASA GOES satellites. The full disk view for the NASA GOES East. Here is our weather.gov map and a bunch of heat advisories, both in the Gulf states and the Pacific Northwest. We'll scroll down briefly to show the key and then say, hey, if your location is lit on the map, click your location. Heavy winds there striking Alaska and heavy heat. So let's start out our forecast with the GFS 72-hour temperature anomaly forecast in degrees Celsius. So it looks like we're going to get all the way up to like maybe 17, 18 degrees above normal there for the Pacific Northwest. Central part of the country there, mostly below average temperatures, and the Gulf states above. So that's a 72-hour GFS temperature anomaly forecast. Here's your 72-hour GFS pressure and precipitation forecast. Strong storms expected to form here over Iowa and Missouri once again, especially Missouri, and also southern Minnesota. They'll be moving almost due east in the coming couple of days. GFS 72-hour pressure and precipitation. And here's your GFS 72-hour jet stream forecast. So jet stream here largely staying north of the U.S., so there will be a lot of convective processes here, perhaps some weather systems moving in odd directions south of that. However, the jet stream in north will see more normally moving weather patterns. It's a pretty solid move there to the east, which will be driving those motions. Next, how about a lightning mapper? That's what's going on in the past about 10 hours. And we were awakened last night by this extremely concentrated thunderstorm here moving across Pennsylvania. It was quite severe. See our Instagram for the lightning map on that. It was pretty out of control. Lightningmaps.org is where we show real-time lightning maps daily on the channel. We want to show folks where terrestrial strikes are happening, and indeed, south of Springfield, Missouri, there are some terrestrial strikes. Pretend you're a horror movie villain, or perhaps Zeus or Thor by forecasting thunder. That is a very concentrated storm. It could be accompanied by damaging winds and hail, but it is a fairly small-looking cell there, so perhaps not. Anyway, there's the full planet view. Next time you hear thunder, check it out. It's highly recommended, powered by blitzachtung.org. If you enjoy the content, press like, subscribe, share, etc. Tell your friends and foes about us. If you're an influencer, drop us a line. Do yourself a favor and subscribe. Why? Because our thumbnails contain more information than entire channels. Because there are channels on YouTube, folks, believe it or not, that are putting out disinformation, misinformation, fraud, propaganda, and agenda-based nonsense. They're selling you bunker supplies. Don't not have a bunker. However, you don't need one for nature. If you want to support the channel otherwise, in a Patreon-like fashion, become a member of the Smash Team. Smashomash.com/Smash Team is our own subscription services site. We launched it back officially in October of 2021 to provide additional content to people who pay for it. It's simply better than Patreon. However, if you want to donate via Patreon and PayPal, there are all kinds of links there on the homepage below this video. Smashomash.com/Smash Team. There's a bronze, there's a gold, there's a silver, there's even a gold annual paid-up subscription level. Links on the homepage, and welcome to the Neo-Renaissance. Did you know we're writing a paper that plausibly explains the mechanism underlying the solar sunspot cycles? It's pretty serious. When it passes peer review, it'll be the most important science paper in hundreds of years. And let's close this thing out with U.S. Doppler radar, clouds and fog over the lower 48, and water vapor. So there's what's going on for all 50 states. Here is the lower 48. Here's clouds and fog. Once again, it's shortwave radiation, part of the interactive weather satellite suite from the NASA GOES. And there is water vapor. Rapid cloud nucleation happening there over Kansas, Oklahoma, Arkansas, and Missouri. Shouldn't be too harsh there, as there is smooth sailing in front of those systems, so there's no dry mass of air for that to collide with and create a huge pressure gradient. That's your forecast. Those will be fairly consistent storms there as they move. They shouldn't intensify too much. So there is your recap. U.S. Doppler radar, clouds and fog, and water vapor, as we bring you the weather all the way from space down to the lower 48. Thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing it exists. We remain frankly surprised. So, in the meantime, I'll have been your host, Dan, a.k.a. Smashomash, signing off. And while I'm gone in the bunker, may that solar wind be at your back. I'm going back to the bunker again. Whoa!